In this video, we're going to learn about net ionic equations in the context of single replacement reactions. So a net ionic equation is an equation that shows only what changes in a reaction, meaning that it omits any spectator ions that do not play a part in the chemical reaction. So if we're looking at this chemical equation here, where strontium displaces zinc in zinc chloride, we are going to ask what has not changed during the chemical reaction. And to do that, I think it's good to just see sort of what there is at the beginning and what there is at the end. I have diagrammed out, okay, here's my piece of strontium metal, and the zinc chloride that's aqueous really should be represented like this, where we've got a beaker and there's some water in it, and note how the zinc ions and the chloride ions are not connected together. In solution, really, they are all separate ions and they're free from each other. So when these two react, when the strontium goes into this zinc chloride solution, what comes of it is zinc metal. So now we have a solid chunk of zinc here, and we have strontium chloride that's aqueous. Although, just like the zinc chloride, the strontium chloride doesn't have the strontium and the chlorine sticking together. It's really just free-floating ions. So if we're asking ourselves what hasn't changed, it's the chloride ions. The Cl minuses are the same. They're aqueous to begin with, and they're aqueous at the end. And so what we can do is we can go from this sort of classic equation that we've previously learned about to what's called a full ionic equation. And to do that, we just say, all right, we've got solid strontium plus, note what I've done here. I've taken the zinc chloride aqueous and I've separated it into zinc positive 2 cations that are aqueous and chloride anions that are aqueous. Note a really key important thing to note here is that that 2 is out in front. It is not a subscript. If it were a subscript, then the chlorides would be connected together, but they're not. They're separate from each other, which is why we have 2 chlorides rather than Cl2 with a negative charge. Anyway, this is the left side of the equation, and that's what we see here, right? And on the right side of the equation, well, now we have strontium ions that are aqueous. They are not connected to the chlorides, so we keep them separate, call them aqueous. We put the chloride separately, call them aqueous. They haven't changed. And then, yes, we have the zinc metal that's solid at the end. So what I'm going to do is just sort of look through here, and I see it's the 2 Cl minuses that are aqueous at the beginning and the 2 Cl minuses that are aqueous at the end that haven't changed. So my full ionic equation actually is written here. This is absolutely fine. But if I want to write a net ionic equation, all I do is I take the full ionic equation and I just cancel out those chlorides because they are spectator ions. They have not changed. Everything else has. The strontium becomes, it changes from solid to strontium positive 2 aqueous, and the zinc positive 2 aqueous becomes zinc metal that's neutral. So there you have it. Net ionic equations in the context of single replacement reactions. Hope the video has helped. Feel free to leave any questions or comments in the comments section below. Thanks for watching.